Okay, welcome back everybody. I see that the rows are filled not that tightly as it was yesterday. This is natural. The decay rate of number of conference participants is typically 10% per session. We have had less, which is good, which means that we are relatively sustainable. There are a couple of housekeeping announcements. As one of our Academy members passed away last Sunday, I have to be out of city tomorrow. So the morning lecture will have a different title, but will be much more interesting than my words. So Maria Paolucci will talk about reputation, lessons from cognitive modeling. You can understand how reputation of scientists or policymakers is created and what is its decrease rate in the, scale of election times. After 3 presentations, there will be, again, group work. Again, it's a best part, almost the very best part of conferences of this type. Opinion of every person matters, and everybody may have an idea which others have overlooked by some reason. So please sign up into groups. The list of groups is available almost everywhere, including internet if you wish, but you may go and just look physically. The classic moderators and conference organizers are probably very concerned because the list of panel members is not indicated in the program. As you may have understood also yesterday, it is intentional. It is meant that every group nominates one panel member to reflect the best ideas with a time frame of 3 minutes per person, and after 5 minutes, the bell will ring very loudly. Is that format okay? So the panel leaders will make themselves very visible after coffee break to lead their groups, to try to find somebody who would reflect the things. The panel leader can also do the job, but then there will be nobody to correct him or her. So that's the point of engagement in terms of academy. And again, everybody's opinion counts, and everybody is extremely welcome to express his or her opinion, but very shortly and in constructive manner, please. Then those who have registered to dinner, please show up. It's not a hands-on exercise, it's legs-on or on-legs exercise. It is Bavarian Cellar, Bayeri Kelder, Roosikrantsi Street, under Hotel Santa Barbara. Everybody has a mobile phone. Everybody has Google Maps. It's just check of your academic capacities, whether you can find this place in due time. We promised hands-on training. We do that with every possible manner. And just general recommendations, go to the south 600 meters, but you can't go there directly. It's not a falling lab here. If you go directly, you will fall. Okay, so then back to the content. Sorry about that. That's a long introduction. So, how to give advice even if scientists are fighting each other with the presence of policymakers? Innar Liiv, board member of the Estonian Young Academy of Science, and of course professor, etc., etc.
Hello from my side. Can we also have slides? So I will start then with, if I can, respectfully disagree with the president about the part that last part of the day is the most interesting one or important one. Then we at Teltech like to think that when we start to talk, then that is the most important part. But the title will be How to Give Advice Even if Scientists Disagree. And I'm, as Professor Tarmo Soomere said, I'm a member and board member of Estonian Young Academy of Sciences. And I will try to reflect back on those perhaps 2 days about my opinions on this topic. And I would actually start by using the most popular question in ministries of Estonia year 2018, which was that what exactly is the problem that we are trying to solve? It's very cool to say whenever you want to, just interact or intervene. And well, I see that there are two inherent meta problems with this issue. Aspect number one is that we still have to invent what is the concept of science meets parliament, not in general science, from science to policy. So we still have to invent that, how to do that, how to actually do that, how to convene that. And second part, what is also a problem, what we must not make illusions of and understand, that for most people this topic is super boring. For young people, politics is boring. For researchers, politicians are boring unless they are just giving money. For politicians, researchers are boring unless they are bringing some evidence to gain votes, and and in general the topic science meets parliaments typically is quite boring for regular readers. So we shouldn't make any illusions of that. We have to think of that, how to make that cool, how to make that important, how to make people engaged more. I emphasize some of the things from European Commission's page, what they think, what science meets parliament should be, specifically how to bring scientists and members of parliament together. And I will try to, in my talk, I will have three really simple ideas or points what I want to make. So I will show this picture. This was very recently also in one other presentation yesterday. So this is a typical narrative or message which is told. So there's a reassuring lie where everybody's standing and an inconvenient truth. Of course, the truth is even harder because science is an evolution. So you have to consider that what was one day lie can become a truth and the other way around. So this makes things even more complicated. So there's no linear process there. I really liked JRC's picture of at least visualization of how a bit closer to reality how policy making looks like. So there's a lot of mess, so it's not linear and so on. And in the end, there's the complex policy making process. And so you can just, if you Google this or you can see the source, you can find this picture as well. So, if the screen starts to work, I have three simple things I want to say. Number one statement, or what I see, the most crucial thing standing in the way of putting together scientists and politicians is that complex phenomena never have 100% scientific consensus. So it's really hard to say that let's make evidence-informed policy making. Not that scientists are fighting, but they are just having different views. They have different scenarios of the future and so on. So there is no point to think that if this is if they ask advice, so what do you do then if even scientists don't agree? I will try to show two things. What I see, some of the small puzzle pieces how to solve. Solution number one, through collaboration, and what we in Estonian Young Academy of Sciences are thinking about that. Solution number two, how to at least help policymakers with some tools to understand where the differences in the scientific opinion are. And those are two things what I want to show them. So I will first build on this argument that, as I said, that complex phenomena never has 100% scientific consensus. There's a really nice line by a researcher at Stanford that a well-accepted theory, a framework for understanding and predicting nature, can always be appended with sufficiently compelling contrary evidence. So just for a second, imagine what should members of parliament do if they have just implemented a policy and then a new news comes out. Whoa, sorry, we were wrong for the last 30 years. So, and the idea is that the process of policymaking is not that easy. So first, that it's not linear, and you never enter to the process from the beginning. Actually, you just enter from a quick cycle or spiral. And just for rhetorical questions, what everybody can ask from themselves is that, how do you actually give advice when there is, and what advice is that when there is, let's say, 50-50 consensus? Some say that this is, but maybe it isn't. What is it if it's 75-25, 90-10, 99-1? For researchers, it's easy. So for the last ones, if it's 99-1, you make fun of them publicly. If it's 90-10, you make fun of them in your own organization or university, in opinion pieces and so on. 75-21-5, you don't give money to them if you sit in committees. And 50-50, you just, you try to give more money to your worldview. But this is researchers' view. But what should politicians do if they want advice? At the same time, it also means that they can always not get propaganda advice, but they can always get advice for their decision. And we shouldn't forget about that. So what are we doing? What are some easy, as the second slide was, that reassuring lies or easy truths or easy fixes, what we can do about it? And I will present two interesting, different kind of projects. Solution number one, Estonian Young Academy of Sciences is actually trying to make a pilot process of the title Science Meets Parliament, and with a pilot of matching 33 members of Young Academy of Sciences with 101 members of Parliament of Estonia. Basically, it means that each member establishes a direct communication channel with 3 members of Parliament. Of course, researchers sometimes are skeptic. Some even say that you cannot divide 101 by 33. That's why it will never work. Of course, there are workarounds for that. The timeline for that, what we see, is May 2019 to May 2021. Of course, it's not trivial. So basically, we have to think about what are the mechanisms. How do you match them? What are the actual events? What would you do? But at least it's a measurable goal, and I think it would be a wonderful pilot, and even a way to show the way to other countries with Science Meets Parliament's initiatives. The KPI, or the measure of success for us, would be, and we have previously pitched that idea as well, is basically that how many scientists are there in the cell phones of MPs. So that is a measure of success in the end. With the program, we hope to have at least 3, right? But let's see what will be the outcome. So far, if we have asked from ministers or members of parliament, what would be how many researchers do they have in their cell phone? Then they typically say that we have the rectors. They're also former researchers, but our idea is that they would have as many contacts to the actual scientific community as possible. So that's solution number one, communication. So basically, the answer would be that we think that we can solve the issue or the obstacle of differences in science by giving them even more contacts to the scientific community. So that will be the success. Second aspect, the new tools. So I understand that the slides are a bit different than the standard slides before. So second aspect is about huge megatrends, what are reaching us, and And how should then scientists deal with that? So this is a slide showing that robots are coming, automation is coming. Typically, in the media, there are two slogans that, robots are coming, we're all going to die. Then if you would ask that, if they would ask from researchers, is it true? Then researchers would have to say, yes, robots are dying, and it's practically true that, yes, we are, dying in the end. But how do you actually solve this issue? Tens and tens of groups have different opinions what to do with this. What would be the impact of automation? What would be the impact of robotization? But how do you then solve that? I will present one project that we did, so with the idea that solution by technology, by providing new tools to policymakers to compare different opinions of scientists. And what we did is we combined lots of data sets. For example, we combined EURES CV and job vacancy dataset. We combined European skills classification and occupation dataset. Plus, we combined the predictions by Benedict and Osborne from Oxford Martin School about which jobs are susceptible for automation. How we did that, just to walk you through in 2 slides, is that first we wanted to visualize the phenomena, but for that we needed to first to visualize the complex nature of labor market. So what we did is that we drew all the different occupations which are out there. This is just a subset or small example, but basically all the occupations which are out there, and we linked those occupations which share most skills. That's a small example that, bus driver and tram driver have some shared skills, cargo vehicle driver and so on. And then we visualized the whole job market, which looks like this. Huge mess, huge graph. But then what we did was that we mapped all the public data about in which occupations there is a shortage of supply, basically where there is more supply, where there is more demand. And after that, we mapped now the prediction of a mega trend. Basically, considering that we now have the labor market visualized, visually, how big part of that is impacted by this automation, by that research group. And with this visualization, you could really see that which parts are there, basically, is there a problem? Is there at all any supply or demand in that in those occupations? And you could, with this visualization, you could easily put together 2, 3, 4 groups. You will get one from McKinsey, one from JRC, one from Oxford Martin School, and then you see, are they different? Are they disagreeing on some parts? And if you have those kind of tools, so that you can actually drill in deeper into different scientific advices, then you can actually move forward and eventually still decide what you believe is right inside and what the voters would like. And a quick marketing plug, so if you want to read the paper, it was published a month ago at Journal of Official Statistics. You just type Megatrend and Intervention Impact Analyzer and you will find the paper. Thank you.
Thanks a lot. And it's a miracle we do have time for a couple of questions without compromising our timetable. Yes.
My question perhaps is simple. Why did you decide to make contacts with MPs if the executives are the decisive power?
Well, so the question was that why did we want to contact the MPs, not the executive part? One answer could be that we just read, simply the idea, the program, Science Meets Parliament. But another aspect is that, of course, we plan other programs as well. But this is tangible. This is something what we can define. This is a set of people which keeps either new people are elected, and there are some time phases that we are actually able to squeeze our program in. And currently in Estonia, the elections are this March. So for that, April and May are the best.
I beg to disagree with your solution one for the problem of how to handle a situation where scientists disagree. You proposed direct contacts to MPs from the Young Academy, and the equivalent solution could be applied in other surroundings, of course. But doesn't that introduce the problem that the MP would then be dependent on one opinion of those disagreeing opinions? And how do you guarantee, except by membership in the Estonian Young Academy, that those opinions are really considered and sort of impartial?
So thanks for the question. Of course, there are no simple answers to that. So I think the crucial answer or crucial question or the core of the question would be that how is that one person correct having that advice? A bit, with a humorous answer would be that for that person it's really good if that advice is taken. So in that case it's not a problem for that person. But in general, if you think about again the social network or the network of as I mentioned it actually on the slide, the informal advice network. So the members of parliament and the members of even Estonian Young Academy of Sciences, but also other scientists are not working in isolation. So they form also networks. So I think that even if it happens that there are 10 members of parliament, each having only one contact, then that information also starts to work in an interesting and complex way. So I think the solution is only that this adds new, let's say, 101 new links, but it's of course it's one start or one puzzle piece in the larger solution.
Okay, I confiscate the microphone. Thanks a lot. I think that you are entitled to carry one of those. Thank you very much. And the list of achievements of the next speaker would fill a few minutes, so I shall skip most of them. But the relevant one for this particular building is that Kari Raivio has been the president of the Finnish Academy of Science and Letters. All other things are irrelevant, more or less. But he will tell about things which are extremely relevant to our today's gathering. So Kari, please.
Thank you, Tarmo, and thanks for the invitation, and dear colleagues. I was not actually given a title. I was requested to speak about the do's and don'ts in science advice, so I picked a title myself, that being the use and abuse of science in societal decision-making. And to start with, there are a lot of grounds for decision-making in society. And number one, I think, in practice is political expediency. This is based upon discussions in a multi-party society, government particularly. The various parties involved in government each have their strategies, and the program of the government is formed in negotiations, horse trading between the various parties, and these issues become extremely important for decisions from then on. And also opinion polls influence political decisions to a large extent. We should not forget the importance of values and ideologies in decision making. But there I would put them in second place after the political considerations, maybe because of a quotation from Winston Churchill, who said that some people change their party because of ideology, and some people change their ideology because of the party. So the party is number one, ideology number two. But it's quite clear that value judgments are important in societal decision-making. For example, in many societies, the issues of abortion, euthanasia are very important in the general discussion in those societies. But euthanasia and abortion are not scientific issues in the sense that it's not an intensive care physician or a gynecologist who has the decisive knowledge in these issues, because they are value-based, not science-based. Of course, economic considerations come into play in most decisions. And then experiential or so-called science knowledge. Now, in many political systems, in many countries, this knowledge resides in the ministries and the civil servants who serve in these ministries. They have long experience of decision-making in their environment, and this is very valuable in a situation when a new minister comes in with his or her own ideas that need sometimes to be dampened down by experience for being unrealistic. The downside of this experiential knowledge is that it may actually prevent any renewal and reforms in a ministry. Authorities' hierarchies are still quite important in decision-making, not only in the military, but also in some other situations. And let's not forget about intuition, which is probably the most important ground for individual decision-making. Most of us live our lives mainly upon intuition. We don't make conscious, reasoned decisions. We live along as we've always done, and it is rarely that we really have to sit down and consider and think of various arguments, pro and con. And this gut feeling seems to be very important in many political situations also. There's a recent example where the almighty president on the other side of the Atlantic sort of neglected the opinions of his own intelligence chiefs simply on the basis of gut feeling. The information that they transmitted was worth nothing. It was the gut feeling of the president that was the important thing. But we would, of course, like to think that scientific information really plays a big role and should play a big role in societal decision-making. And we talk about evidence-based policy. But, and there is a special characteristic of scientific information which actually would justify it playing a larger role, and that is the self-correcting nature of science. So, there might be disagreements, as we heard in the previous talk. The scientific community is rarely 100% in agreement, but the disagreements are usually sorted out in renewed experiments, and in a way the science corrects itself. It may never reach the truth 100%, but it can certainly approach the truth in a better way than any individual through intuition. But there are two sides to decision-making and science advice. There is the demand side, which is represented by various decision makers at various levels, starting from the high international organizations, United Nations and EU, and going down to city councils, municipalities, And at all levels, it would be advantageous to have a rational basis for decisions. Also, the civil servants in ministries and municipalities who prepare legislation, they would need the scientific input at an early stage before the proposed law is put in front of the parliament, because by that time it is usually too late to make material changes. The media needs also scientific information to judge whether, in its watchdog role, to be able to judge whether the political process is going on the right or the wrong track. And then the citizens, they are entitled to know on what grounds the decisions are made that affect them. And basically, they are also a very important target group for transmitting scientific information, because the opinion of citizens about science is decisive for the way that politicians treat science and promote the well-being of science. Now, what is the information needed for? Of course, planning of policies at various levels, preparation, follow-up of legislation, budgets, and so forth. International negotiations is an area that is very important, particularly for small nations. Because, unfortunately, in this world, it seems that those nations that have the largest number of population have a much larger weight than their opinions would sometimes deserve. There was an interesting example of this when Finland joined the European Union in the mid-90s. There was a lot of negotiation going on and discussions, and there was a study done by a research institute that interviewed all the main negotiators from the Finnish side who had dealt with these negotiations, and asked about how they progressed and what was important there. And one of the conclusions was that if a small country wants to get its voice heard, that voice has to be backed up by good, rational arguments. And there was a quotation from one of these interviews that if a German makes a stupid comment, everybody still listens to that. But if we want to get our voice heard, we have to have good, solid evidence. So let's not forget, in the small country context, this important aspect of science diplomacy. Then addressing crisis situations is very difficult oftentimes for governments, and there would need to be a system, sort of a 24/7 service to provide advice in those circumstances. But then the societal responses to scientific breakthroughs should not be forgotten as a reason for providing scientific information bottom up to the decision makers, because they wouldn't even be aware of the problem if the scientific community does not bring it up. An example is, of course, climate change, which was created by science, basically, because the average man on the street would not have any idea that the CO2 level is increasing, temperature is increasing, and so forth. It is science and the credibility of science that is behind all these issues. Now, the supply side then, who are the providers of scientific information for decision makers? Of course, the knowledge producers, universities, independent research institutes, either national or European, like the JRC. But then private sector should not be forgotten, because they are responsible for about 2/3 of the R&D investment. Unfortunately, their knowledge is usually protected by various IPR arrangements. So universities and research institutes. But these are not really equipped to provide information for political or societal decision making. Universities have their own interests. They want to have academic freedom to study whatever they want to, and are not particularly interested in supplying politicians with science. Research institutes depends. Some of them are actually harnessed to serve the interests of society. Others are fairly independent and like universities in that sense. Then we have a lot of knowledge exploiters who take scientific information produced by others and then use that for advisory roles, like in various advisory bodies, or for making money as consultancies, think tanks, interest groups, and lobbyists. And then, of course, enterprises. And then are the academies of science, which in most countries are not research-performing organizations, with some exceptions. But they can be regarded as guardians of knowledge because they are merit-based, they elect their members on the basis of their scientific agreements, and they are politically impartial. But there are problems on both sides. On the demand side, the biggest problem is lack of interest or awareness among the political decision makers. They are very busy, and they are approached all the time by various stakeholders and whatever, and to give their time and interest for actually finding out about the world of science is unfortunately often lacking. Then they have the problem of where to look for the scientific information if they would happen to be interested in it. Of course, Google is the first place to resort to, but that Google is a very unreliable source of information. It is totally unfiltered. There is a lot of good information, a lot of useless information, and an equal amount of false information. And to decide which is which, what is quite difficult. A fairly good source turns out to be Wikipedia, which has replaced these huge tomes of encyclopedias that used to be the pride of bookshelves in many homes. And Wikipedia has replaced that and is a useful and oftentimes, most of the time, a reliable source of information. But again, a little uncertain. Civil servants, some of them have good knowledge and political aids of the decision makers and their own contacts to the world of science, but these are not systematic, and it's oftentimes are not perhaps well versed in the problem at hand. The knowledge producers, exploiters, and guardians don't have functioning channels into the decision-making process. Now, what kind of information? That's quite understandable. That it has to be relevant to the matter at hand. It has to be reliable. Some kind of a quality guarantee should be there. Impartial, compact, because few politicians will read anything that is thicker than one sheet of paper. And therefore, I'm afraid that the excellent reports, for example, by ESAC, which you have available there, I doubt if many politicians have the energy to read through them. So they have to be somehow summarized and presented in a concise way, and in an understandable language. Different timetables of political and scientific processes have already been mentioned, and then the hazards of cherry picking. Because especially the knowledge exploiters are masters in cherry picking, meaning that they, out of the huge mass of scientific information, they pick the pieces that happen to fit their current agenda and forget anything that might speak against it. And that is a real problem. On the supply side, one of the main problems is how to critically analyze and popularize an avalanche of information, because scientific publication is expanding really like an avalanche, and it is impossible for any individual to keep track of what is happening. For example, I just this morning looked in PubMed, which is the main biomedical database, which contains most of the published peer-reviewed literature in the biomedical field, and put in diabetes as a search term, and got 655,645 hits. And if somebody had it in his head to find out something about diabetes, it would be a daunting task to deal with this kind of an avalanche. And therefore, what is the solution in this case is systematic reviews, which medicine, in fact, invented in the late 1980s, so late, 1980s. And since then, have published over 3,000 treatment recommendations based upon systematic review of existing scientific literature. And this approach could certainly be applied in any field. Take all the literature, evaluate it critically, and act on that basis. The frantic pace was already mentioned, and how to communicate the degree of uncertainty was also mentioned. Disagreement between scientists can be real or it can be trumped up. Real disagreement is actually part of the scientific process, because an amount of skepticism is in place whenever some new scientific finding is reported. The first reaction is skepticism. Is this true? Can it be true? And then when other scientists repeat that, and if they get supporting results, then the credibility of the result keeps increasing, or then it is torpedoed and forgotten. But a skeptical person will eventually believe when enough supporting evidence is piled up. But then we have this group of denialists who not only are skeptical, but they deny the basic tenet of a new research finding or an old one. And denialism is oftentimes based upon suspicious motives. This has been quite clear starting perhaps on the 1950s, when for the first time it was clearly shown that tobacco is a cause of lung cancer. Then tobacco industry mobilized a denialist movement that tried to doubt the results of the research, deny its importance, and present trumped up arguments against it, and sort of play for time. And the same thing happened with the climate change, which has a very dedicated group of denialists who still deny its reality, and many or most of these have economic interests in the form thinking about fossil fuel industry and countries that are dependent on fossil fuels. So denialism is something that has to be dealt with, and it is only a near consensus of the scientific community that can overcome this type of a problem. And then, of course, some members of our scientific community take an arrogant attitude towards the political world and consider themselves somehow to be above those issues. One must admit that on the political side there are similar persons who take a very self-sufficient and congratulatory view of their own importance. So it's maybe a general human property. But anyway, the supply and demand of scientific information do not meet, and the research that has been done on this area usually has come to the problem that the main problem is on the demand side. There is not sufficient interest in the political sphere. Now, why is a valid scientific viewpoint discarded? And I'll give you some lessons from political discussions in Finland, where this problem has become quite evident. Oftentimes there are political agreements. It is said that we cannot do this, even if it's scientifically motivated, because it is not in the government's program. And this, in our multi-party government, is for them, valid argument for 4 years. Then when the new election comes and new government comes, then there is a hope again of getting some change, but not until then. The power of lobbyists is very strong. The main lobbyists are the industry and labor market organizations. Both employers and employees organizations are afraid of that jobs might be destroyed. For example, in the context of forest industry and what we should do with our forests, very clear. Legal misinterpretations, it is often said that we cannot do this because the EU prohibits it. This seems to be one of the main arguments that the Brexiteers have presented in their campaign, and falsely. Economic arguments, of course, values and ideologies in our environment, it is always the welfare state that is being threatened in the mind of politicians. Precautionary principle is basically a valid principle. It states that if there is something, a chemical or a food that might cause a health hazard, we better prohibit it until it becomes quite clear that it is safe. But, and this has been very clear in discussions about genetically modified foods. But it is impossible to prove something safe, 100% safe. And at some point one would need to take a more rational approach to this. Opinion polls, of course, weight of authority, and in Finland particularly, if they do so in Sweden, it must be right. But I would once again say that lobbying is a very suspicious way of making your bread. This is the lobby of the lower house of the British Parliament, which is where lobbying was born when people approached the MPs before their meetings. And in many countries, the weight that industry and various interest organizations have is really strong but hidden. And even in a country like Finland, which always is near the top when countries are ranked according to how little corruption there is in society. Lobbying is a hidden corruption that does not become evident in these assessments, but it does have a tremendous effect on political decision-making and often placed upon cherry-picking scientific information. I'm touching something that's not. Now, Eurobarometer is a Europe-wide opinion survey that tries to sound out what Europeans think about in various issues, and it's very reassuring for the scientific community how great trust Europeans placed upon researchers, both in universities, research institutes, and also in companies. Much better than in civil society organizations, and on the bottom of the list are the politicians. So we have an advantageous situation in this respect, because the people trust in science, and we could have a good argument for placing science at a higher position in decision making. It's funny actually that in the Finnish opinion polls, it's about what institutions in society people trust in. It's always the police, the defense forces, and universities are the top three. And so it seems that in Finland people trust more in science than in God, because religion comes much lower down on the list. But this is something that we should try to maintain, this trust of citizens in science. Now, a couple of years ago, Nature published a list of 20 tips for policymakers to interpret scientific claims. And these are some examples from that list, which are self-evident for scientists, but perhaps not to policymakers. Real difference and chance can cause variation. That's, of course, so. No measurement is exact. It can be pretty close to exact, but never 100%. Bias is rife. Bias in performing research, publishing research happens, unfortunately. Correlation does not imply causation. Even though the decreasing birth rate in Central Europe went exactly in parallel with the number of nesting storks in Europe, the lack of storks cannot be said to be the cause of the low birth rate, and something like that. Regression to the mean, controls are important, and so forth. I don't know if this kind of a list would convince any politician, but might be considered to be too perhaps difficult to interpret. But in any case, the editors of The Guardian newspaper then published their list of 20 things scientists should know about politics. And this starts with a statement that making policy is really difficult. And I guess this has to be agreed to. It is not easy to make societal decisions. Policymakers can be experts too. It is very irritating for such individuals who are quite well acquainted with science to be talked to by a besserwisser who thinks they are children. Policymakers are also human and have various motivations. Starting policies from scratch is rarely an option. It is easy to take a problem and think about its solution if one had a clean table to start from, but that's very rarely the case. And of course there are a number of other things that were pointed out in this listing. We need more research is the wrong answer, and even more wrong is we need more money for research. Why the voice of science is weak? The media, especially social media, have a wrong view on fairness and impartiality, because it seems that they think that every opinion has the same value and right to be heard. And thus you have these discussions on television where a real expert in health or nutrition or whatever is brought to talk with a self-appointed expert who has followed a diet of his own invention and lost 10 kilos of weight. And this type of an attitude from the media has caused many scientists to decline from appearing in public in these types of contexts, which is understandable in a way, but then it leaves the field to the forces of evil who are not based upon any solid information. And then there is something that is called Brandolini's law, or the bullshit asymmetry principle. And this states that the amount of energy needed to refute bullshit is an order of magnitude bigger than that needed to produce it. And this is well known, particularly from social media, where bad news demonstrably spread much, much quicker than good news, if good news are presented at all. And this makes it at times very exasperating to fight against false information. And then there are not really incentives and rewards for the scientific community to be active in engaging with society and decision makers. The rewards and incentives are still mainly in scientific publication and citations, and we would really need to incentivize our colleagues to be more active in this area, because we really have a duty towards society and decision makers to make sure that after a dumb decision, a politician can never give "I did not know" as an excuse. And that is up to us. A few concluding comments. In a changing world, the importance of science will increase. I think that's quite clear, because so many things that the so-called progress involves are scientific in nature. And I also suspect that the difficulty and reluctance to make decisions in the climate change problem, to really cut down on emissions, is based upon a hidden wish within politicians that some technological gimmick will be invented that will take care of the CO2 and the problem, so that they would not need to make the painful economical decisions that this entails. And that's, they can have that hope, but if it's hidden or obvious, then they should not at least cut down on research funding, because without that, that gimmick will not materialize. Evidence-based policymaking seems to be gaining acceptance. It is partly due to these international developments at the United Nations and the EU level, And in many countries there is a great deal of interest. There is an international network of government science advice that has biannual conferences. One was just last November in Tokyo. And the information and good examples of how to approach politicians and how to give the advice is increasing. But the leading principle must be remembered, and that is that the advisor advises, but the politician decides. We are not decision makers, and one has to be careful in making policy recommendations. One can present various options, but the final decision must always be the politicians. One thing that should be improved is the scientific literacy of civil servants. It's fine to appoint scientific advisors to ministries, but more effective would be if the personnel in the ministry would itself be more sophisticated in science. Because in the long term, that would be a permanent improvement to decision making. Clear guidelines and structures should be established, and also for emergencies. And we should defend the special role of scientific evidence in comparison with opinions or experiential experts, because of the self-correcting nature of science. And finally, science has to maintain the trust of politicians, media, and public, and that is a duty for us all. Thank you very much.
Don't sneak away. Don't sneak away. I know you're always disappearing after saying things which really hurt the audience. That is question for clarification already, yes. With the ladies.
Me, okay. Sorry. Sorry, Kari. I know you are former president of the Finnish Academia
That's
of Sciences.
intentional.
Yeah, I want just to clarify. You said that abortions and euthanasia are questions of value, not science. I think with euthanasia, you meant assisted suicide is the question of value, because euthanasia is based on top science. Euthanasia is mostly done when the brain death is determined, and it's a very big science. I can right now, I can give you here in Estonia the names of 2 families who were told that the children are brain dead. They are well now. It's very big science, and brain death is kind of a new area of science, and it's a ground for hunting organs also. So it's very important. It's not a question of values only.
I think I know something about these issues because I have been running a neonatal intensive care unit for 30 years. And I know that euthanasia is not a medical problem in society. It is an ideological and values question.
Yes, Tom.
So maybe just a small comment or something that I would like your opinion on is that in your conclusions you do not speak about media, about press, about newspapers. And I think there is a huge problem with media because they are not disseminating in the correct way most of the time the results produced by science. So what is your perspective on that?
Well, the media is in a key position, of course, both with respect to politicians and to the general public. And it's really disturbing how the media landscape has been developing lately. And it's the spread of fake news and disbelief just because somebody says so. It's something that can only be corrected by the media, but by changing their behavior.
But that's not self-correcting then, right?
It's not, but they need the input from the scientific community, and I think we are talking here about science and politics, political decision making. But another area that really needs improvement is the relationship of science and media. Because it's only through science that the media can be sort of educated to do better.
Okay, thanks a lot. There will be coffee break and dinner, and Kari will be then only coffee break, I heard now. So thank you very much, Kari, for all that. And now we are switching a little bit more to science. Mario Paolucci, who is representing the network Future ICT 2.0. It was actually the competitor for the future and emerging technologies networks, in which the winners were a human brain and graphene. So instead of giving us 1 billion, we were given 1 million and told that do what you can. But there is a good interpretation of Future ICT 2.0 in terms of tennis and Estonian language. In tennis, you don't say 6 against 0, you say 6 love. Okay? In Estonian, if you put full stop after a number, it means something different. So it's Future ICT second love. Welcome.
So thank you everybody and good afternoon. I hope you're not too tired. I'll try to be quick and to the point. So let's just introduce myself. I have originally a degree in physics, but I've completely forgotten everything about that. And now what I do is a mix of cognitive science and I'd say artificial intelligence. My two big projects have been a project on reputation, on which maybe you will know more tomorrow, on that what was called IREP, and ended with this nice booklet. Now it's quite outdated because it was produced a long time ago. But this was a booklet meant just for diffusion at the politician and companies level of things that could be done with reputation technology. And the other big thing was this Future ICT huge project that frankly has been kind of vindicated by history, because if you think that we proposed not only big data liberation, but also the creation of control centers for understanding what was happening to society, and we proposed this with something like between 5 and 3 years before the emergence of populism. Well, some of those observatories that we had proposed, I think that they would be really useful today if I had been established. So Future ICT, the original proposal, the big one, was about building this small green blob that you see there with the planet underneath. I'm not going to read everything, but this was a list of things that we would wanted to do. This is the big version of the same. And to sum it up, it had 3 key components, apart from the fact that you see again the word reputation in the center. But it had a platform for participation at different levels. A sensor network that Estonia has realized independently with my great happiness, and a simulation part. The simulation part is the part that essentially is still lacking in this field. And that was my original field of research, so I'm very keen to see if something will come out from this simulation. At the time, we called it a project for a living Earth simulator. Well, the project didn't go through. We have a smaller project instead running now, which is also supporting this meeting, that's called Future ICT 2.0. Of course, if the project didn't go through, it's also our fault. I mean, it had some issues inside. It was a bit too vague. Maybe the technology wasn't ready yet. Maybe we weren't convincing enough. Maybe we weren't the right people. Analyzing a big failure like this, I think it's also important for scientists, because when you try to put together all those people with something that looks like a good idea, but in the end, you don't manage to convince the Commission that this was urgent is something that social scientists should also analyze. I really like that we've said several times, scientists also are human. So when we plan, we should also remember that we have to distinguish between the advancement of ideas and the struggle of people. I have recently read again the dispute between Hooke, who was an extremely important physics researcher, and Sir Isaac Newton that came after him. And he was the president of the Royal Akadeemia after Sir Hooke, and he removed all memories of Hooke because they have had horrible disagreements. From the physics point of view, it's extremely interesting. The first and top disagreement was about the nature of light, because I'm not sure I remember it right, but I think Hooke thought that light was a wave, and Newton was certain that light was a particle. And they fought like they destroyed each other over this struggle, while obviously they were both right. So the man is something, and sometimes people can be destructive for science, because people are people just like politicians. They have ambitions. They tend to personalize science. We have to see the message behind the struggle of the people behind the science. Anyway, let me get back to the Future ICT and its mutation in this much smaller proposal, which is Future ICT 2. It's a relatively small thing, which is now centered on promoting a cooperation between hard sciences and social sciences, so everything that's in interdisciplinary, multidisciplinary, transdisciplinary work. And we have a specialized subgroup on blockchain, and we also had a simulation part, so again, trying to do something like the Living Earth simulator, but much smaller, but we had issues with the fundings. I don't want to enter into that, but maybe at a discussion I will show some details. Anyway, just to give you an impression of what Future ICT 2 is doing, I will send a video now, a small video that was produced by the, I hope it's here. Great.
The digital transformation is exciting. It also has potential downsides, such as increased unemployment and the threat to democracy and individual freedom posed by the abuse of personal data and artificial intelligence. Our economies still largely run on natural resources, but climate change and resource shortages lead to political instability and even military conflict, while increasing migration places demands on societies. To tackle the unprecedented global challenges that humankind is facing, we need to collaborate using smart tools and leveraging the power of diverse ideas.
The aim of Future ICT 2.0 is to put our social, political, and economic systems on a more sustainable footing. We bring together a broad group of scientists, tech startups, civil society institutions, and individuals.
Young and emerging scientists conduct research, which combines cutting-edge information and communications technology with social science. They design and build interactive systems that adapt in real time to real-world events. Our node in Latvia, for example, is running simulations in order to adapt bicycle route networks to local needs. Our Italian node is conducting large-scale simulations to understand the formation of social norms that help prevent climate disasters. And our Swiss node is experimenting with a new, multi-dimensional financial system. Our current system is good at pricing goods and services, but bad at valuing social goods, such as an unpolluted environment or a stable democracy. By harnessing the power of the Internet of Things and blockchain technology, we can reach the planet's sustainability goals much faster.
Complex global problems are not insurmountable, but we have to act now. Future ICT 2.0 will provide a new sustainability toolbox.
Okay. So, as you have seen, it was just the video was just a film presenting some of our initiatives. Of course, it's a promotional video, so things look better than they are. We're working hard. I think the Latvian peoples are very advanced with their simulation. We're very much behind with the simulation on norms. And the Swiss group is making progress on the blockchain things. We have several blockchain initiatives, including hackathons. One is just in these days, and if you check the website, they will be announced. More will be announced. So if you're interested into the what they call the Finance 4.0 initiative, just check our website. But let's come back to our issue now that I finished the presentation of the projects I come from. And for what concerns policy, I'm more or less going to say what is my point of view about, my personal point of view about the issues we have touched. And I think that we have an issue with science and truth and an issue with society. And simulation, I think, can help. So after reviewing quickly some of those issues, I will present some simulations that that have been developed or that we have been developing as examples. And then I will just let you draw your own conclusions. But what I propose is that simulation is a tool that will play a role in the future. So this was to answer a question that came out, to give my answer to this, came out in this discussion. Is science just another opinion? Well, the answer depends on the context. So we've just heard that we can never be 100% certain, but that's in the matter of things. And for what concerns hard sciences, we can get very close to that. So hard science is the best way to solve current problems in that field, and there is essentially no alternative, no shortcut. We still have very, very difficult problems. Who knows about the EM drive? Yeah, well, not so many people. So I use that example because it's a classic example of something that shouldn't work, but it seems it's working. Essentially, it is a special engine that is designed with a microwave cavity, and this seems to be capable to producing a thrust which goes against the laws of mechanics. They still are measuring, in some laboratories are measuring thrusts, in some other laboratories they are not. It's very likely that there is a big mistake somewhere in this because it goes against basic principles. But we still don't know exactly what the mistake is. It could be something extremely complicated, as if that actually when you're giving energy to the machine to work, the cables where the energy runs have something to do with the magnetic field of Earth. So extremely complicated. But by repeating the experiments and finally by sending some of those things in space where a proper experiment can be done, powering them on, you just see if they go forward or not. If they go forward, then we have to rethink some big parts of science, of our basic ideas. If they stay where they are, then there's nothing new. There was a mistake, and we're still back on Earth to find out why these two situations are different. So where this small thrust that we see is coming, because it's coming from the laboratory, not from the machine, somehow. Social science is much more complicated. There are lists of reasons why this is complicated, and for me, the two most important are always the same. The first one is that people react to changes in society, and most often react in unpredictable ways. So it's completely different when you study a passive system, essentially, even if it's tricky, which could be studied by hard sciences, and when you study an active system. If you study an active system, that system will study you back and interact with your changes. So if you think that something in economics, in sociology could work, then you should also take into account the reaction of people to this, to your proposed policy changes. So social science is completely different with respect to hard sciences, and we have to remember this when we think about ways to make it work. There have been many disheartening false results in social science recently. I have, well, there is a classic here, which is the psychology researcher Dr. Stapel. He was a very famous psychology researcher who produced striking results about how people changed their behavior depending on their context. And he became very famous when it was discovered that all his experiments were completely made up. Some of his PhD students at some point called out saying, "Professor, but why you are doing all your experiment yourself? All the other PhD go on the field and do the experiment. You're doing all by yourself and then you give me the data to analyze, but I want to do some work too." And essentially, this guy just got everything, went to his house and filled out all the questionnaires by himself. The damage that he did was huge because some of those results are very plausible, so they might be true. But now all the ideas about these psychological results are being discredited, and the field has suffered a terrible strike. Again, you have to separate what we know from the people that do the job. What went wrong there? Well, my interpretation is that this was one of the effects of the shifting incentive structure, in which we have now very strong incentive that, well, let's sum it up with the publish or perish pressure. If you go back to my example of Newton and Hooke, struggle between scientists and unfair ways to prevail have always been there. And if you go, bad statistics is also a big issue. There we have serious issues with statistics because of the way we have considered significance had been naive for a long period of time. Now we're slowly coming out of this, but essentially you will have seen those papers saying that more than 50% of published results aren't true. This was due to an excessive freedom of search, in which when you try to analyze the results from an experiment, and also, I mean, and this is being compensated. I had here another example, but I've been overmatched by the previous one that has been shown with Trump's advisor, which was even more clear. But this is also very relevant for policy because it was a big result that the famous, now infamous, Reinhardt and Rogoff's paper that said that if a country has a 90% ratio between the gross national product and the debt, then it will, his national gross product will decrease. And this was the result of ideology and inability to use Excel. I consider Excel very dangerous for research and invite everybody to move away from that. But of course, ideology was a serious part. So, are scientists good at policy? This was another question that came around in this discussion. And again, my answer is simple, is just no. Scientists may be good at offering new solutions, it may be good at telling you that something is impossible, even if even this could change, yet they are subject just as anybody else to ignorance, bias, and ideology. Scientists, that was a point that I made in some comments, should remain scientists and try to advance knowledge. As soon as they are asked to influence policy, then all those other factors enter into play. And what it means to remain scientists, well, my first recommendation is just to remember that the idea is to question everything. So Richard Feynman was one of the most famous researchers in physics in the second part of the last century, and he wrote that science is the belief in the ignorance of experts. And he speaks very highly about the freedom to doubt. I was running a check of statements that some of us have made, and me too. I often find myself trying to propose those statements. Let's go up on the slide. Scientists should remain scientists. Do I have scientific proof of that? No. I am proposing a policy measure on the basis of personal conviction. So you see how difficult it is to get out of this attitude. And several things that we say that science is good, we need more funds. Don't interfere with our job, that's something that I often say. It's not just enough to create knowledge, we have to feed back political needs into the research cycle. Why? Do we have a demonstration that this will work better than the alternative? So when we try to decide, we should remember that sometimes we can't run an experiment or find proof of everything. But we should distinguish the small parts in which we have proof and the big parts in which we are trying to using something else, which is tradition. Humanity worked on tradition for millennia until the scientific method was found. The scientific method, when you're lucky enough that you can have scientific data, and then you can stop using tradition and values and everything else. Well, society. I think that Future ICT video was more than enough to illustrate this slide. This is just a list of issues that could be addressed. You could also refer to the millennia issues. Or, just the method here was interesting because this list of issues that Future ICT produced was created through one of those so-called Hilbert workshops in which you convene some experts on the social science and try to convince them to create prioritized lists of big social issues to solve. What can policy do together with science? We're back to the different timing problem. Also of this we have seen several examples. Essentially the Academy takes 1 year, and that's pretty fast to produce some recommendation. It's impossible to do it faster, and yet policy cannot wait because the issue must be produced right now. And just a comment on something that was also repeated several times in this meeting, which is that policy cannot fail. I think I have several counter examples, starting from big programs can fail. Think of the shuttle program in the United States. That was a big fail. They tried to keep those spaceship runnings. They were our only spaceships. Humanity has no spaceship, only the shuttles. Now we don't have them. And yet, even if they try hard to make them work, it was technologically impossible with that level of resources and organization. That was essentially an organizational failure. Again, Richard Feynman was involved in the investigation. But also think of budgets. I have recently known a researcher that studies state budgets, and it says that what is prepared in the several, we've seen that plot with approval, and they say that what's planned and what's executed are very often completely different, and there's so much guesswork. It's amazing that those things effectively hold. And here, just a simple provocation that I think it's useful. I invite you to think about this question. Is the relation between science and policy symbiotic or parasitic? On which side? Well, we have a long set of issues to solve. They've always been there. They're not special of modern times. The difference with modern times is that now we're starting to see a way to address them. Because, wars, terrible organization of societies, prejudice, destruction of natural resources have always been there in the history of humanity. I think that simulation is a good new tool that could slowly be added to our way of thinking. To work, it must permeate our approach to planning the future. So what I'm saying here, that simulation is used in science and engineering. Is this not much used in policy planning? Why? Why? Because it's extremely difficult to foresee what will happen to the society as a whole, and most of the policies that we can choose will affect the society as a whole. We can't create small areas in which the policy effect will not ripple out. So to do an effective planning of the policy, we need to be able to simulate the future. Of course, there will not be only one future. We will be able to simulate a set of potential futures. Can we? And to this, I had the opposite question. Can we not? At some point, we will have to. And this is like at this point, normally one comes out with a philosophical argument of the simulation, which instead I found this nice comic to summarize it. So the argument is very simple. If humanity will ever produce a simulation of the future, then there will be a lot of simulations. Then if there are so many simulations, it's extremely likely that we now are one. So if there are more simulations than realities, it follows that most apparently conscious beings are also simulation. And so the comic character arrives to the conclusions, I think, therefore I am not. And the other character comments, you know, the unexamined life is looking better all the time. Okay, so do we have something in the field of simulation? I'll show you a couple of examples very fast because I'm running out of time, but just to give you the idea of things that can be done with the current level of technology. And if you want it summed up in 2 words, it's not much. So this is the in most simulation textbooks, social simulation textbooks, is the oldest simulation ever performed by Schelling. It was a simulation of segregation. It wasn't done by a computer. In fact, the story wants that Schelling was doing this on his kitchen floor tiles with plates and other things. And essentially, it has an initial state which is mixed, in which you have households of two different kinds. Each of those has a limit tolerance for neighbors of the other kind. If you move those randomly until this desire is satisfied, you obtain a segregated situation. This is not especially surprising. This is what the recipe does. What is interesting is that you could expect a linear relationship between the desires of people and what they obtain. Possibly, people should obtain what they want. So if I want to have if I don't want more than 50% of other people around me, I should end in a situation in which I have about 50% of different people around me, because that's my tolerance threshold. If you put this together with the characteristic of two-dimensional space, you will find out that this simple requirement of having just 50% of people like you around you brings out a situation in which you have 100% of people like you around you. Because the system keeps moving and creates this kind of separation between the two groups. So you get much more than what you asked, and not because you're doing strange things, because that's how the space is done. This is the prototype of what I call an agent simulation, and gives you an idea that you could not have before. It's also a classic example of ideas that can come from the field of complexity. So it's very different. If you know some basic idea of complexity, you have a good set of tools to understand the social reality. Consider the tipping point. A tipping point now is so common that probably most people know what it is. When a phenomenon has some kind of internal feedback or nonlinear feedbacks, then it could exhibit behaviors in which it seems that nothing is happening, and then when some value goes over a threshold, everything flips in the other state. This is a nightmare for policy, because you don't know that something is happening, you keep tuning things, saying everything is going well, and then suddenly everything goes wrong. There is a simple model for that, which is it's a model of forest fires, coming back to forests, that shows just this kind of behavior. And you tune some parameters, and it seems that everything goes well, and everything goes well for a long while, and then, as it happens with those complex systems, in a moment that you can't predict, the entire forest burns out in a single step. And that's not what you wanted. It's very difficult to prevent. So this is also a case of that kind. A very simple model gives you an idea that you could have some kind of amplifying effect that give you, even in the presence of small preferences, give you large segregation. Now, what does this simulation do for a policy? It just gives you an idea. If you try to tune this accurately with a realistic number, then you're asking too much from a simplified model. It's not obvious that the model will tell you what happens in reality. And now, in the last 5 minutes, I will present you a model I'm working on right now, which is a model of another kind. In this case, we're really trying to do the other step, and we're trying to simulate a specific situation in a specific city accurately at the single individual level. This is done with European fundings, and it's about organized crime and terrorism. We're actually two separate models, and I will just give you a generic idea of how we are trying to do it. We have a simulation with something like 10,000 agents, and we try to build these agents as accurately as possible using national statistics data on everything. So this simulation has many features that are directly comparable to a specific population. Of course, we're very far for reproducing everything, but at least for the list of interesting traits, we should be very close. On this thing, we apply a theory. In this case, it's not my field. We're working with criminologists and other people, experts of the field, and they have told us, in their opinion, which ones are the main theories. This is work in progress, but when we put this together, if we observe some effect, then we could say that in a plausible situation, and if the theory is true, then we could get some effect which is comparable to what we have in reality, and then policy happens. Because then we change something in this model, and we see if there is some change and in what direction it's going. So we got we had a good dissemination support. So we managed to get on the UN academic impact just like a couple of days ago. And well, this is a bit too much detail. Anyway, we have, as I said, we have two models, organized crime and terrorism. And the computer simulate multiple heterogeneous plausible agents that interact through plausible mechanism. But more than the plausible part, I want to stress the idea that we are following some specific theory of why and how, for example, crime is organized. If I have to commit a crime, who will I choose as my co-offenders? 2 minutes. So yes, I probably said everything that is in those slides. So we want to conduct randomized experiment testing scenarios and policies and obtaining the results in silico of potential policies that we can't have in reality. We can run long-term simulations. One of our partners wants to run for 50 years. We let him do. But frankly, I mean, at this level, we will have to do a lot of work of interpretation to see if this result has any sense. But we can do a lot of experiments here that would be also impossible in reality for ethical reasons. So this is just to give you an idea of how things happen. We're trying to create all those networks, and the same individual is in that picture is going on the vertical line. And he's not, for example, if you look at the topmost left individual, he's not a criminal, but he's friends with other people. And if you follow the thin line of friendship, you will see that there is a criminal on that line. He's not working, so he's not has no network for professional school, and his family is isolated from the other families. This is the model of crime in which the possibility to commit a crime essentially navigates on those networks that we create as plausible networks. And that's it. I mean, so I was back to what simulation is and a set of principles of simulations, but I think I'm running out of my time very fast. Well, you don't always need to run simulations like that. You can do with dynamic systems, and you can do with just statistics. If you do with statistics, you will probably only see linear effects. If you have an effect that is linear, that's fine. Dynamic systems can also add the complexity and non-linearities. But what our approach has, which is pretty unique, is the possibility to give special roles to individuals. So to create simulations that also have one of the important characteristics that you see in societies, which is a very unequal distribution of characteristics. So in our simulation, it's not difficult to create, for example, in network special hubs that respect some kind of power law, or to create situations of strong inequality, while in dynamical systems, when you don't model the single individual, that's much more difficult to account for, and some social effects may be strongly influenced by this kind of inequalities. Well, yeah, I wanted to just to situate this discipline. Is agent-based modeling the same as the big data approach? Not really. The big data approach tends to be theory agnostic. This is very important for me, that when we develop those simulations, we decide, or we ask the experts to name their theory of reference. If you do the classic big data approach, it's much easier that you're hiding your ideologies in the way you read your data. We're normally pretty open about the kind of choices that we do. If our theory is there, if it's ideologically biased, at least you know it. So agent-based modeling makes theories manifest. And is it the same as artificial intelligence? Well, AI is a specific technique that is born from artificial intelligence, so we still have a relation to it, especially in the technological field of multi-agent systems. And this kind of simulation was born from distributed artificial intelligence. Is it mature? This is a recent paper. I will not comment on this beautiful London tube map-like plot of maturity that lists an enormous set of ingredients that we need to be mature. The paper is from this year, so pretty recent, and studies the state of our discipline with essentially marketing techniques to see in which position we are now. Even if the first simulation that I've shown you, the Schelling one, is from the 70s, we're still in the early adopters phase. It's not clear if this means that we're going too slow, or we just are accumulating knowledge, trying to get to the point in which it's really useful. I was comforted by the history of meteorology, weather prediction, essentially, because I was told that essentially from the moment in which all the theoretical apparatus was in place to the moment when computers started churning significant numbers, they needed 20 years just of technology, improvement in precision, sensor, and such. So you can have this kind of long period and stay in the early adoption phase for a long time. It has several disadvantages, but there is no more time, so you will not see them. You will only remember the advantages. And yeah, there's several people I have to say thanks to, including, first of all, Julia, which is the co-director of my laboratory, and Nicholas that made all the setup work on the Proton project, and of course to Future ICT. And I'm very thankful to the Estonian Academia and to Tarmo for the invitation to this beautiful city and this fantastic workshop. Thank you, everybody.
Thanks a lot. It makes clear that it is possible to glimpse into future, but it's extremely complicated, and you need agents for that. And agents are not artificial intelligence. Are they?
They were born as a subfield of artificial intelligence. We have very simple agents right now. I've tried to build cognitive agents. We really are not ready yet, but there are some platforms for those of you who are interested. I can tell you about that.
And Kuldar, very short, please.
Yes, it is short. I have a question about future ICT, this diminished project, as I was a part of the original proposal. So you mentioned blockchain and several other technologies, but what role do agent-based simulations play there in this small future ICT project that is going on? Thank you.
The plan was to have an example of a large-scale simulation in the second future ICT. This was proposed as, one of the building blocks, or at least a demonstration of feasibility for the Living Earth simulator. That was one of the key ingredients. What we really did was not that much. You have seen it was like 1/2 second in the video. They say that we're working on the norms it's the evolution of norms. And I didn't touch on that, but the plan was to study how norms play a role in those games. The games are exactly the same as Tom presented, so we already have a knowledge about that. But we try to manipulate that game, convincing people that there is a norm that says you to do something, or that you can imitate what they do. Those two aspects are cognitively different. So the norm is different from just a rational argument or an imitation argument. The idea was to use the results of the experiment then to run a simulation, a large-scale simulation with agents built with this capability to use norms. We finished the experiment, which is already something. It will be published in next year, and we're still starting with the simulation.
Thanks a lot, Mario. We can have more of Mario today and tomorrow, but at that stage, thanks a lot.
Oh.
We do distinguish between people, as you have seen. Thanks a lot, and just a few housekeeping issues before going to coffee break. After coffee break, there will be group work. Some of group leaders you have seen already, but some haven't been really visible. So Milena Rajkowska arrived just by lunch. Show yourself a little bit. Yes. And Kevin Parnell has been always sitting in the last row. He has perfect eyes, eagle's eyes. He's there. And Oliver Wertno, he always comes in time. Normally, if he doesn't show up, then his group will be spread among other groups. But just to mention that the group leaders are extremely different. And when I picked up comments from the three speakers, then what actually Mario made sure from his Schelling's models that a simple way how God punishes us is that he fulfills our wishes. And then two people mentioned some numbers. Kari Raivio mentioned that policymakers can be experts too. And Dinner Leave tried to build a competition between parliament members who has larger number of scientist contacts. So it's my pleasure to announce a competition here. We have 6 group leaders. They are very different. Just to characterize how different they might be, Oliver Wertno is coming from a small institute of cybernetics. In the backyard of this institute was growing Skype, and in this institute were created mathematical foundations of blockchain and Bitcoin. Small institute in Estonia. So there are technically 6 leaders. There will be 2 questions about person. It's very personal. You all know what is the age index in science. It's a number of papers you have published with citations over some threshold. First question is, try to make sure who from the group leaders has the highest age index and how high it is. And second question, to make sure who from the group leaders has the largest number of PhD or higher degrees. The person who will have answers to those questions will be privileged to say the second toast on the dinner. Why the second? The first toast will be definitely said for science and parliament. And the third toast, I'm being now recorded, so I have to be politically correct. It's about beautiful imbalances of genders. So with that, competition is open. You can start working and you can start coffeeing. Welcome.